Hello and welcome everybody to the Join Technaura and Imply Real-Time Data Analytics webinar. Thanks for joining again. As I said, I hope you can all see me or see the screen and hear as well. We will record this webinar and we'll share the content post-event. So you will have a recording after this as well. My name is Mark and I will be your host through this webinar. I'm a Senior Business Development Manager at Technaura. And we'll be joined by our experts from Imply, Helma, and our CTO, Michael, from Technaura side. Also, we will have later on joining us as well our Senior Data Engineer, Rahul, and our CEO, Krishna. Okay, let's get started with the presentation. So, who are we? Who are your hosts today? So as we all know, generating streamed data in real time from different sources like databases, for example, mainframe systems or IoT devices is very challenging. And we are Technaura. Technaura is a leading real-time data solutions consultancy that helps you to build real-time data solutions with the likes of Apache Kafka, Spark, Akka, and other top open source technologies. We have offices, our main office in Mainz, Germany. That's close to Frankfurt for the people who don't know where Mainz is. And a footprint in the Crypto Valley in Zug, Switzerland, and also in beautiful Budapest, Hungary. We have another office. Technaura covers basically the full 360 degrees of the real-time data ecosystem. Starting, for example, with migrating legacy systems to modern architectures, and also we do aggregate data flows to deliver instant and actionable business insights for you. So Imply, Helma is going to, of course, go a little bit more into detail later on, but just a brief summary. Imply is a high-performance analytics solution to store, query, and visualize event-driven data. And Imply was founded in 2015 by the creators of Druid. This Technaura Imply partnership actually powers real-time data ecosystems that are fast, agile, and scalable, and are low code and low cost to deploy. And basically in this webinar, we will showcase how real-world challenges similar to your own, hopefully, can get resolved through these real-time ecosystems. And at this stage, I would actually like to hand over now to Technaura's CTO, Michael, who will dive into the data solutions part of the webinar. Okay.
Yeah, thank you very much, Mark. So, good. So, real-time data is something what came up when the data streams increased, and there was always kind of a contradiction whether processing data fast and really near time or processing big data. So, and that's why was technology developed what allows both. So, and what are the trigger points to go back from or go away from a legacy technology of handling data in a bigger application landscape and go to real-time data. So one of the big points what might let you think about changing the approach you are going to data is if you feel that the data streams what you are processing are becoming bigger and bigger. And so this always or very often means that the value of data is changing by time. Very often you have the high value of a certain data in a very near time to the ingestion of data, and the value of the data is dropping after some time. Sometimes the value of the data is already dropping after some hours. So, and that's why big and increasing data streams is a trigger point to think about, change the whole picture to process data in real time. Another point is consolidation of the integration between systems. When you think about going away from a point-to-point interface structure and creating a kind of a data backbone to your application landscape, then you might also think in general to do it right at the first time and process the data when it occurs, and not only after some time in the batch mode. So the next reason what could let us think about real-time data in our IT is if you feel that you have quite a lot of data and all the data has some, let's say, some average interest, but there are occurrences where of high interest of the data, and you want to process these occurrences very, very fast. This is, for example, the case when it comes in the flow of financial transaction to the detection of some fraud, and you want to take actions immediately. So for that, you need to have an infrastructure that allows you to pick out of a big data stream some isolated transactions. So this requires some technology that allows this. Another point, what might let us think about real-time data is bringing into the architecture microservices. Microservices very often lead to some redundancy in the data. And this data redundancy has to be managed by some services what synchronize the data between the different microservices. And for that, the technology for real-time data is a very good way. So now we have in the middle of our slide, the topic what we want to address in a focused way today. This is if you need to have real-time analytics. With analytics, you have very often the situation that it is very comfortable for slicing and dicing data, but the data as such is very often not the latest one. So, and this is leading very often to the situation you have a nice analytics system, and you need to have some operational reporting what is working against your transactional real-time data. So if you have real-time analytics, this is combining both. You don't need to have two different reporting systems, but for that, you need to have the analytics and you need to have the transport of data to the analytics. Yeah, then there are four other points. One is the cloud migration of systems. Cloud migration means you have to rethink a lot. This is a big investment, and once you are doing this, you might also think about real time at that point, because in the overall project, this is not really bringing too much complexity to this cloud migration project. That's why it's a good point to rethink and do it right. The same for the spin-off function from a mainframe. Again, big projects is quite some complexity, and when you're doing this, it's a good idea to bring in this real-time data approach. So decision support by applying machine learning by nature is something where you want to have quick responses by the system based on the latest data, and this requires bringing the data to ML at the right time. So the last point here is, if you want to keep historic data in a sequence when it occurred, when the technology of real-time data allows you doing this as a kind of a side effect, and that's why here, this is a good way of doing this. So these are different ways, trigger points for thinking about real-time data, and you can find in almost all industries use cases for this. So Mark, next slide, please.
Yeah.
So with real-time data, of course, this is not only the bright side of life, we have also some challenges, but we have to address. One is almost a natural one, but you have to keep in mind, if you want to talk about real-time data, we have to keep all the chain of data in real time. This means from gathering through transport and processing, all the systems has to do this in real time. If one of the systems is not allowing this, then we have here a bottleneck, and this might negatively impact the whole architecture. So the next point is the data must be treated as event stream, as a sequence of incremental changes rather than versions of a large data set. So this means take the data when it occurs, send it through the technology stack, what is putting this into a sequence, and bring this to all the systems what are subscribing to these data. Another point is for analytics. The data is floating, so this means there's only limited ability for pre-calculation in analytics, what in the old world very often was the case. So this means analytics has to be highly dynamic and has to deal with the data, what is changing all the time. The next point is many data sources. We are not only talking about massive amount of data, but very often also many sources. And this is bringing another set of challenges in the architecture that we have to deal with them. Yeah, and the last point, what I have on this slide, is the high availability of the architecture. So in the old world, you might even not have noticed if some analytics was not working for a certain period of time. If we are talking about real-time data, then we want to have the data all the time in real time. This means we have to keep the architecture in a way that is highly available. Smart home brings you instant visibility on home sensor events, and for many users, for many events at the same time. So you could imagine this is something where you want to have the data in real time, and you want to have, and you might have many sources of data. So, and here the Imply approach to this real time allows you to deal with more than 10 billion events per day, 250 million users, and very short response time of less than a second at many queries. So this is one of the examples where IoT smart home is showing what real-time, what the use of real-time data could bring to your customers. So the application performance monitoring. So everybody who is working in a IT operation knows this problem. You have many systems or nodes, and all these systems are generating many events per second. And you have specialized engineers who are following if the systems are working properly. So for that, it is not that easy to really keep all these things in a way that engineers can react in a timely manner. Very often engineers get informed too late, or we understand the root cause of a certain. So this approach here allowed to even think about new SLAs and new use cases for IT engineering stuff, and gave him the chance to react very quickly on some problems what occurred in a large environment. Clickstream, viewership, and advertising. So in the online world, you want to react on events or on the user who view your website. Maybe they are clicking some stuff, you get unfair, you might offer to them something, or you want to react on a request of a user being on your website. So for that, a real-time approach is practically unavoidable. So this allows you to have all the different events, even from many websites in one system, and pass this through to either machine learning environments or to staff who are taking care about people watching your website. So here Imply created also a system what allows for many users, many events per second, a very quick response, and brought the right information to the right audience of users who take care about the websites. So this was a short overview on the real-time data and possible use cases. And I would like to give back to Mark.
Yeah, thank you very much, Michael, for this. We would like to actually hand over now to Helma from Imply.
Okay, yeah, thank you, Mark. I'm going to tell a little bit about Imply, my role. I am a sales engineer with Imply, based out of Germany, and I've been with Imply for a year. But who is Imply at all? Imply was, we talked about it already, it was founded in 2015. And the story is that there were three folks that worked at a company called Meta Markets, where they, so they were in the area of digital analytics, clickstream analytics, and they had analytics requirements to analyze large amounts of data really fast with a low latency, and they needed to have fresh data near real time, and they didn't find any tool on the market that could fulfill all their requirements, so they designed their own. They donated the main core of their development that was called Apache Druid. They donated that to the open source community, and with funding by Andreessen Horowitz and some more venture capital firms from Silicon Valley, they set out to found their own company, which was to become Imply. Imply is headquartered in the Bay Area in California, but we are nowadays global. We first acquired customers in the USA. Like there are customers like Amazon, Twitter, Visa, and many more. Walmart is also one to be called here. We set out for international expansion, and nowadays Imply is present in all global regions. Our offering is a fully fledged analytics platform built around Druid, which is high performance near real-time analytics data store. And I'm going to talk a little bit more about my offering in the next slides. Here you see the same along the timeline. We are now in 2021, and we are also expanding really quickly and with a lot of new customers in Europe. What are our use cases? Our use cases are at the intersection of business intelligence and operational intelligence. So operational intelligence is where you really want to see how are your processes developing right now. How do you want to intervene if something goes wrong? So you would find use cases in network, cybersecurity, APM, IoT, manufacturing, all of that. But we also, and at the same time, have a very strong offering in the area of business analytics, where it's more about slicing and dicing your data, grouping your data by various dimensions, and getting aggregated numbers out of it. And then again, in near real time, so that you know what exactly is going on in business right now. This all based on the super fast engine, but we also noticed very quickly that just having an analytics engine isn't going to cut it. That was the fallacy of many of the open of the NoSQL vendors during this Cambrian explosion that happened 5, 6, 7 years ago, where there were so many new databases and each of them had their own language, and then you had to program around it, and so it was difficult to really work with it. So what we also noticed is that you need to democratize analytics, because you would find very few people that can actually program. Professional data analysts that can work with data in various forms and shapes and with various query languages, you find a few more, but there's a whole lot of more people that can work if you give them an interactive graphical analytics tool with which they can analyze your data very quickly. So you give the analytics capabilities into the hand of business users. So that is one important part of our story. The other part is because we have low latency and high freshness, so we enable hot analytics use cases, and this makes us makes Imply a very interesting solution, even for customers who have already a fully built or like up to date, you could say, state-of-the-art analytics solution, and we see that quite often. Here, for instance, you have a customer that is using a real-time bus already. So we have with Confluent here, it could be Kafka, it could be Amazon Kinesis as well, it could be various technologies. They use this to deliver data to a data lake. There's various processing steps. They are already moving over to microservices for the data processing. And then there is a data warehouse in a modern architecture that would live in the cloud. It could be something like Snowflake, Redshift, Google BigQuery, anything. It's quite flexible. However, there is always a lag between generation of data, something happening in your business, and when you really see it in this analytics system. There is a certain amount of grinding that has to be done. A lot of it still happens in batch mode, and that is where you lose time. So for these customers, Imply comes in as a nice augmentation, as a complementary service to the data warehouse, where you can connect either to your data lake, or you can connect directly to the event bus and get insights about your business and how it is developing in near real time. How we build this is in an overview shown here. You have in the dark blue section of this layer cake, as I like to call it, you've got Druid, which is an open source core, but we've of course got our own enhancement to it. And we've built the layers around it that you need for an enterprise analytics platform. This is how to get data in. You've got connectors, you've got data loaders that we supply as extensions that you can get with our platform. We've got an interactive ad hoc analytics tool that allows you to get into a conversation with your data. And I'm going to show this in the live demo a little bit later, which comes with real-time alerting and anomaly detection features. And we've got what every enterprise tool has to have: management, security, and monitoring capabilities. A few words about the technology. I just said at the beginning of my presentation that these folks that developed Druid originally, they couldn't find anything on the market that fulfilled their requirements. And so here's an overview, and it looks quite complex, but I'll walk you through it. Here's an overview of what makes the Druid core special. We can ingest data from various data sources. Some of them are batch oriented, so you might have your files sitting in a database or sitting in cloud storage. Others are more real time, so you connect directly to an event stream. These data are ingested, and what happens is this is a highly distributed shared nothing architecture. We've got so-called data servers that handle ingestion and data serving and a sharded kind of querying. We have got query servers that bring the results together, and we've got master servers that coordinate it all. And our biggest customers are running hundreds of servers. It is so scalable, it is super flexible. You can add new servers on the fly, it balances itself. It's really cool. What you see here is in the big part, ingestion and tiering. This is what is going on the data servers. As data flows into the system, it is loaded by the data servers in parallel from various Kafka partitions, for instance, or from various subfiles, loaded into memory and cut up into so-called segments. Segments are basically time chunks, and then again you partition your data optionally by another key. As these segments are filled up, you keep them in memory, and there they are already queryable. However, what happens when one of these time chunks is full? So for instance, you say, I'm going to cut up my data stream into segments of 1 hour each. After the hour is gone and you've waited a little bit for late coming data, then data is transformed into a new format. So before and until now, it has been row-oriented in memory. Now it is transformed into a segment format. These segments, they are column-oriented. The data in the segments is dictionary compressed, bitmap indexed, then zip compressed again. And with that, we create a highly efficient storage format. Once such a segment is created, it is immutable. It is only read, it's never written to anymore, which also, by the way, eliminates a lot of concurrency problems. These segments are put to an archive, which we call deep storage. That's typically cloud storage, and then it is sent back to the data servers, where it is queryable. So on the data servers, we have these real-time segments that are still being written to here in the purple sector, and we've got historical segments that are immutable, highly optimized. And then we've got the query servers a little bit to the right, which bring it all together. They know from our master services where to find which bit of data. They automatically bring these different flavors of data together to give you at any moment in time an up-to-date picture of what is exactly going on in your business. And the nice thing is this scales not only towards almost an infinite amount of data, because it can just add more data servers, but it also scales very well in terms of allowing many, many concurrent queries. You can also add more query servers, and because there's a lot of smart optimizations in there that eliminate concurrency. So this is why it's super fast. The result of a query can then be viewed in our own pivot tool. It can be viewed with a lot of standard business intelligence tools, because we also offer standard APIs here. We offer JDBC and we offer a REST API, and you can also use the data, consume the data in your own applications. For queries, we support our own query language and also standard SQL. And that is basically how the technology works. What we see a lot happening, and this is actually the picture that I like the most, this is how we really build a real-time analytics architecture. You start with generating all kinds of data from various sources. You collect them in an event streaming platform that handles it handles data delivery, but it also has built-in persistence and the capability to process data. There's usually a certain complexity, and this is why we partner with companies like Technaura that can build these architectures for you. And on top of that, we connect natively and directly to these event streaming platforms and give you an advanced analytical view of everything that is going on in your platform that mirrors in near real time what is going on in your business. Here are a few cases of, I wanted to show this shortly. It's just, they are summarizing the advantages of our distribution over Plain Druid regarding ease of management, time to market, and enterprise-grade security. Here are a few use cases. These are reference customers of ours, IronSource. It's an app monetization company. So basically what they do is those mobile ads that are in games and other mobile apps. And they switched from their previous solution to Imply for analytics, and they're saving more than $600,000 a year. Their application got 700 times faster. This is not a typo. And they also saved a lot of maintenance overhead, so they could free some of their DevOps engineers for more productive tasks. Another poster child customer of ours is Twitter. Twitter are using they're using Imply for their own mobile ad platform for analytics internally as well as customer facing. They've embedded our front end into their own application, and they're using this to analyze more than 100 billion events per day in near real time, handling more than 200 concurrent queries at any given time. Walmart, another one that I like. Everybody knows Walmart, the big retailer in the US. They are putting more than 10 terabytes of data per day into Imply. They're using it for inventory and pricing management. So that's how they optimize their business. They can see exactly what is needed where, and then they negotiate prices with their own vendors according to what they have in store and what they need. And this is also my segue to the live demo where we are looking well, obviously not at Walmart data directly, but we are going to look at data of a global retail company. And this company here, you just see an analyst's dashboard. We are now visiting, we're looking over the shoulders of the analyst, and this analyst is looking at data on the dashboard where you see here. We are active in various regions. We are counting the transactions right now for the latest day, but I can just as well change the filter here, and I could even have various data sources in my dashboard. And as I change my filter, it will be reflected in all the tiles of the dashboards. I've got some information here about top products, top regions. I've got a map overview. And if I want to drill deeper into this data, well, I could just go ahead and click into any of these tiles, and I get the interactive view where I can filter around and play around with it. And I have this opened here actually. So this is the most basic. This is what we call the cube view. And it is a business intelligence view of real-time data. So it brings together the real-time features of that you know from observability, APM, time series database solutions with the business intelligence capabilities that you have here, full analytical capabilities. I can here, I'm counting transactions. I can pull in the time and see how it develops over time, change my time filter again, and you see it's really snappy. I'm going to look at the latest 30 days now. Yeah, this is nice. And then let's pull in the country. The country is geocoded. The tool recognizes it, and you see immediately how your sales is going on in all the world. All these charts and graphs are interactive. I can click into this if I want to look at the US data. And let's break this down by region. So this. Now counting transactions is maybe not so interesting. So I've got my dimensions to the left. I've got my measures to the right. And here you can see anything that you would want to use to define your KPIs. You can actually define your own here with a very simple expression language that is currently also moving to standard SQL. You can do things like, okay, I don't want the transactions now. I want to have sales and profits, let's say that. And I want to compare this to the previous month. And then you see how easy this is. I can actually choose the period here that I want to compare with. And now let's pull in something like the product categories. And I want to see the top 5 products. Here, that's the top five products. By region, so I'm going to look at the sales per region in descending order. Let's remove the transactions. This is just cluttering the graph. Yeah, and now let's say I want to use only a I want to filter on a metric. I can do that as well. I can say I want only those that where sales is beyond a certain limit. I can add this filter, and then I see, oh, all my sales have been going up except in a few cases here. So if I want to know what's happening here, I'll just select this piece here. I could go and drill deeper into it to do root cause analysis, or we come with the built-in anomaly detection feature, which by itself will tell me exactly what is different about these bits of data than all the rest. And this is a valuable help if you want to go interactively into looking what is there, what is this kind of little spike, or why did this drop down here, why did my production going down, why did my sales go up? And one question goes to the next, and with this really very interactive, very fast and very snappy GUI, we make it a delightful experience to really look at the data in detail. It comes with a couple of other functionalities as well. You've got various visualization options here. You could look at your data in a sunburst chart, for instance, or you could look at it in a tree map. So there are really a lot of options that you have. I'm now going back to the table, of course. But another thing that is a relatively new feature that I like very much is the crosstab feature, where you can see if you look at, I should pull in this here. When I look at, say, region and country, and the row should have the category. So then what we have here is our crosstab view, which is a kind of an infinite Excel table. And you see it is now giving me my metrics. It is computing everything on the fly. As I drill into any of these categories, you see in the first moment the numbers are not there yet, but as I open it up and I scroll, then the numbers are only those numbers that are in the current viewport are computed on the fly, and that improves our performance big time. And this is what we are working on to make this even better and better all the time. Pivot also comes with built-in alerting features. If I have something like, say, my sales would be going down compared to the previous period, my sales goes down more than 10%, then I want to be notified, and then I could have this sent by email, or I could send it by webhook to any application that basically has an REST API. We've got Slack pre-configured, but you see here it's a very simple thing how to configure the API contract for any kind of application out there, what they expect in terms of alerting format. So much about Pivot. There is a lot more features there that, in the interest of time, I will not touch now, like scheduled reports, like SQL pass-through, and fully integrated role-based access control on a row and column basis. I want to go instead, I'm going to move away from the analyst space, and I'm going over to the next person who is the data engineer. So that is the person who actually brings data into Imply. And this is also where we often bring big gains in efficiency or cost savings to our customers, because it is just so easy. We come with a fully integrated wizard. This console here is the work area of the data engineer. And even data, now let's assume I'm a data engineer and I'm going to onboard a new data source. These data that I'm going to load or going to ingest, they are stored in Kafka. So I'm going to connect to Kafka. I need to know where my Kafka server is. This is here. And I'm also going to have a Kafka topic name. And that is basically all I need to tell the system. And it's going to read data from Kafka. Here I get a preview of my data. Imply parses a lot of data formats automatically. This here is JSON, but you see also there's a lot of other formats also supported. Imply has, well, I mentioned it before, if you listened right, that we have time-based segments. All data is partitioned and sorted per time. So I'm going to need a timestamp, but it's actually going to find the timestamp for me. And then I can apply my own transformations and some filters. And just like that, I've created my data schema and I'm ready to ingest my data into Imply. I still need to tell the system what kind of segment granularity. So do I want to have hourly or daily or weekly or whatever partitions? I'm going to make it, oh no, let's make it daily. So let's make it daily. And I want to read from the beginning of the Kafka stream. There's a lot of things that I can configure, but that I normally don't need to touch. So basically, I'm now ready to go. And if I hit submit now, then it will start loading data. I could also do some manual editing here for advanced users, but I don't have to. This is basically how it looks when I set up ingestion. When it's running, it looks like this, because I've done this before, obviously. So I think we've got this here, store sales Kafka latest, and I can see here, oh, this is all happy. It's in good shape. And how has it been doing? It has been doing quite well. And I get some statistics about how it's doing. Talking about statistics, I also need to make sure that my performance and my reliability is all there. And for that, we come with built-in monitoring. Now, the nice thing is, because we have a real-time capable analytics tool already, nothing speaks against using that tool to monitor itself. And that's what we do. And this is, we call this product Clarity, and it comes integrated with our platform. And Clarity means that we collect data in Druid and we send them to Druid again. And we have this data explorer, which is also based on the Pivot technology. So it really looks very much like Pivot because it's based on it. And this gives you an overview of query performance, ingestion performance, and anything that you need about the health and the performance of your cluster. So if I want to look at the queries that I ran during this demo, I could just look at, I could just select the time range here. So let's do that. And then I want to filter this by username because I don't want to see other users' activities. So I'm going to pull in a filter, and this is me. I'm going to select myself, and then I want to know how my query performance has been. So I want to see this in a table, and I'm going to collect this into 5-minute group bys, and then I see this is my query performance, 98th percentile, less than 200 milliseconds, and this is what we see in a lot of production systems because you can always scale your clusters accordingly. If I had a slow query here, I would pull in the query ID, and I could use this to diagnose the problem. Let's go back to the table view. Then you can see each query ID, and for each query ID, you can exactly see how long it ran. Finally, there is the aspect of operations and lifecycle maintenance, and we've built a management console around Druid and Pivot. This is our Imply Manager. It gives you access to all your important API endpoints. It has built-in security, and it enables you to run a rolling upgrade without any downtime just by clicking, selecting a new version and clicking apply. It allows you to scale vertically or horizontally. If I want to have more data servers, I would just set the instance count higher. I can scale the data servers. I can have various tiers of data servers for hot and warm and cold data. I can have I can scale independently, scale my query servers, and I can scale my master servers, and I can also set configuration capabilities here. Like for instance, I can here is where I enable specific extensions for Druid enhancements that we package with the Druid core, and I can set low-level options to each of the processes if I want to, and it will be rolled out to the entire cluster. And this is what a lot of our customers like, because it makes the life of the DevOps teams that maintain these clusters so much easier. And with that, I'd like to hand back to our host, Mark, and I think we are now open for questions.
Yeah, thank you very much again, Helmer, and as well, thank you again, Michael, for your presentations. I think this showed really well how the Technaura Imply partnership powers real-time data ecosystems and how real-time world challenges based on these examples can get resolved by these real-time ecosystems. As you just said, we would like to open the forum in a second. I think as well, just to highlight, we as Technaura basically feed Imply with aggregated data so that they can do their analytic magic. So just to summarize that in super easy words. But I'm sure that we have a few good questions coming up as well in a minute.
I have a quick question. First of all, thank you for the demo and for the presentation. My name is Safi. I'm from Tabula. The company name is Tabula. I'm from Israel. I'm not a data engineer in my profession. I'm part of the SRE team, and we are using Druid, not Imply, but Druid OSS to analyze our data. The most interesting question for me is on part of the deployments of Druid or Imply. I can see that in some of them there is an ETL or data processing like Flink or anything similar, any similar technologies between Kafka and Druid. So I wanted to ask when we should use this data processing platform like Flink and so on, and when we can ingest directly into Druid from Kafka.
Maybe I can take this one. Thank you, Tsachi. The general case is that if you have your data nicely laid out in a Kafka topic in the same way that you want to see them in a table later, then you can ingest directly into Druid. if during ingestion you want to do simple transformations or filtering, you can still use just Druid or just Imply. So basically, whenever it is simple event processing, if you want to do complex event processing that involves, for instance, pre-aggregations before you ingest or enrichments. Okay, enrichments you can also still do in Imply, but some enrichments you would still do in pre-processing. Joining data streams, you would do that in pre-processing. Anything that requires stateful processing of data records as they are in Kafka in connection to previous records or records that are, you know, related. That is something that you would usually do in a stream processor upstream. Does this answer your question?
Regarding what you say, a percentile calculation, is it considered basic transformation or basic calculation that Druid can do, or should I use the data processor before I'm ingesting the data?
Oh, that's actually a good one, and thank you for this. This is a very good question. I haven't really touched on that yet, but it's actually one particular strength of Druid that you can do percentiles on the fly. And what we use is data sketches that give you a very good approximation of these metrics, because doing a percentile in the exact way would basically entail to count through every single row of data. And if you have a lot of data, that will take a lot of time. So what we do is we create so-called data sketches, and these are implemented inside Druid. So we can compute them in Druid. Although I heard just a couple of days ago that some companies like Nielsen actually do that also upstream. So there may be reasons to do it upstream, but you can definitely do that in Druid. And the real percentiles, you can then, based on whatever set you are analyzing, whatever filter you set, you can always compute these percentiles on the fly in an approximation with less than a percent error, and much faster than anybody else out there.
Oh, thanks. So it shouldn't affect the performance of Druid, the ingestion rate of Druid?
No, marginally.
Okay, thanks. I have another question.
Go ahead, Saki, go ahead. The room is yours.
I wonder what are the differences between Imply and Druid, except what the slides that you showed before with the comparison. I wonder if the core, if the Druid OSS is the same, and Imply just brings the pivot system and the visualization. Basically, this is the question.
Almost. So the core is always the same, or at least compatible. We are usually up to half a year ahead of the Apache community. You would get new features from Imply first. In the future, we may also add some features that you will only get in the Imply distribution. What we've already done is we have added some extensions to Druid that are commercial extensions, but the core is, at any rate, is compatible. As you probably know, with Apache Druid being an Apache project, that means that there is a project committee that needs to approve any changes and any developments. And as a commercial organization, we can move faster and we can release a new version of Druid faster than the Apache community. And that's what we do.
I see that no one else asking questions, so I'm allowing myself to ask more and more questions. Does Imply provide professional services to customers that doesn't purchase the Imply solution?
No. the answer is a resounding no.
Okay.
We have one of the reasons why we help our customers with time to market and operations is because we can provide these resources, and because it is with Imply, like, or with Druid, like with many advanced tools, companies are struggling to find the resources on the market, the right kind of engineers. So we reserve our consultants, and we have highly qualified consultants, but their time is reserved for our paying customers, I'm afraid.
Understood.
We do have community support though, and we support the Apache Druid community, and there are also highly qualified folks that help you there.
Oh, cool.
And I'm working quite closely with these folks, by the way.
Great. Good to know.
Okay, great. I mean, if anybody has any other questions, please let us know. I think we have no questions from the audience at the moment. We've nearly reached our hour as well, so I think that's a good way to wrap up. And I'd like to thank everybody for your time, for joining, for listening, for asking questions. As mentioned, we will reach out to you and share the content, and feel free to reach out to us if you have any questions at all. So yeah, if anybody, Michael, Helma, you have anything to add, please do so now.
No. Thanks for the opportunity. Thanks for having me, and I wish everybody a great afternoon.
Thank you. Cheers. Bye.
Same to you. Thank you, everybody. Goodbye.
Thanks. Bye-bye.
Bye.